In this video, I will talk about the normal distribution. A continuous variable is a variable that can assume any value on a continuum. It can assume an uncountable number of values, such as the thickness of an item, the time required to complete a task, temperature of a solution, height in inches. These can potentially take on any value depending only on the ability to precisely and accurately measure. So there are different types of continuous probability distributions. We also have uniform distribution as well as exponential, but we're going to focus on the normal distribution. The normal distribution is symmetrical, it's bell-shaped, and it ranges from negative to positive infinity. The mean, median, and mode, if the graph is perfectly symmetric, they will all be equal. The mean is located in the middle, and the spread is determined by the standard deviation sigma. So you'll see it better in this graph. So the mean is in the middle, and the standard deviation determines the spread. So when you change mu, it shifts it from left to or right, and when you change sigma, that increases or decreases the spread. So there are a lot of things in the real world that are normally distributed. One good example is height. Um, you can have extremely short people and you can have extremely tall people. But there are very few very short people, and there are very few extremely tall people. The majority of the heights will be in the middle, which would be your mean. Okay? So if you look at these graphs, the bell-shaped curve can change depending on your mean and your standard deviation. So in this picture, A and B, they both have the same mean. They're right here in the middle, but they have different standard deviations. So as you can see, graph B is a little bit more skinnier than graph A. Graph B and C, they have different means, and they also have different standard deviations. So in order to figure out normal probabilities, we look at the area underneath the normal curve. So the area underneath this curve is 1. The whole thing is 1. So you can find different parts of different areas, and that will correspond to probabilities. So first let's talk about the standardized normal distribution. This is also known as the Z distribution. In these cases, the mean is 0 and the standard deviation is 1. So the values that fall above the mean, those will be positive Z values, and below the mean, they will be negative Z values. So we talked about Z values before, Z scores. Those are basically how many standard deviations you are away from the mean. Okay, so let's look at this example. It says, given a standardized normal distribution with a mean of 0 and a standard deviation of 1, what is the probability that Z is less than 1.57? So they told you the standard deviation, the mean is 0. So we know that's right here in the middle. We want everything less than 1.57. So let's say this is 1.57 here. We want this area to the left of 1.57. We want everything less than that. So I'm really big on drawing pictures. I think it's very important that students see the visual behind this. So there are two ways you can do this problem. You can use a standardized normal distribution table, or you can use technology. So for these couple of problems that I'll do, I'm going to show you how to use the table. Okay, so this is what a normal distribution table looks like. You'll find it in your appendix in your book. This is not the whole table. These are just the positive z-scores, and then another one is the negative z-scores. So this table gives you the area to the left of a z-value, and that's exactly what we're looking for. So if you look at this picture up here, you see this little z, and it shaded to the left. It gives you the area to the left. So how do you read this distribution table? Well, the z-value is made up of three numbers. Okay? The first two numbers here you find going down. This last number you find going across. So in our case, we're looking for 1.57. Okay, so we're going to go down to 1.5 because that's the first two numbers. And then we're going to go across till we get 7. So here's the 7 here. It's actually 0.07. Where these two meet up in the body of the graph would be the answer. So I'm going to go, keep going, keep going, keep going. It's right here, 0.9418. Okay, so this area here is 0.9418. So the probability that the z-value is less than 1.57 is 0.9418. So this is the same scenario, except this time we're looking to see whether or not, what's the probability that z is greater than 1.84. So once again, the mean is 0. Let's say 1.84 is here. This time we want everything greater than that. Okay, well the thing is, the graph or the table gives you the area to the left of that. So I'll go ahead and draw it. The table will give you this red area, but that's not the area we want. We want the one that's in black. But what we have to do is we need to figure out the area in red. Once we get that, we can subtract it from 1 to get the area in black. Because once you add the red and the black, remember the area underneath the graph is 1. So adding these two colors up will give you 1. So let's go ahead and we are going to look for 1.84. So we're going to look for 1.8 going down. That's here. And then we want the 4 going across. So we're going to go till we get this number here, 0.9671. All right, so this area here is 0.9671. So to figure out this area here, we're going to take 1 minus 0.9671. Okay? So when we subtract it off, we get 0.033. And that's the answer. So the probability that the z is greater than that is greater than 1.84 is 0.033. Okay, the next one asks, what's the probability that the z-score is between negative 1.57 and 1.84? Okay, so this time we have a negative z-value. So let's say this is negative 1.57. And over here is 1.84. So we want the area in between here, between these two values. Well, to do that, the first thing you're going to do is figure out the area to the left of 1.84, and we did that up here. We said it's 0.9671. Okay, so we're going to write it like this. We're going to find the area to the right of 1.8, to the left of 1.84, and then we're going to subtract off the area to the left of 1.57. Okay, so we already know this area is 0.9671, but now we got to figure out the area to the left of negative 1.57. So I couldn't fit the whole negative z-score table on here, so I just did a clip of it. So we're going to go to negative 1.57, which is here, and then go, negative 1.5 and then go to 7. And where they meet up is here, 0.0582. So we're going to subtract off 0.0582. Okay, so when you subtract that off, you should get 0.909. So that's the area in between these two, 0.909. Okay, so now I'm going to show you how to do this in StatCrunch, and I'm also going to show you how to do it on my Excel template. So let's go back to the first problem. Z is less than 1.57. So we're going to go to Stat, Calculators, and we want to go down to Normal. And the one thing I like about StatCrunch is it actually gives you pictures. So we already know that this is a Z, so our mean is 0 and our standard deviation is 1. We want less than, I got the problem already, 1.57. So right here I'm going to type in 1.57. I got the less than. If you click on this drop down, you're able to change it to less than or greater than. Okay. If I hit compute, it gives me 0.9418. You can just round. And that's what we got before, 0.9418. And as you can see, it gives you this visual, which is pretty cool. And I always draw my pictures so that way, if you do it in StatCrunch, you want to make sure that your picture aligns with the picture that you drew. So there you go. All right, so if we do the next one, greater than 1.84. So we're going to change this to greater than, and we want 1.84 here. Hit compute, and that's similar to the picture that we had, that we drew earlier, and we get 0.0328, and you can just round 0.033, right? And then you also have a between button. So we got negative 1.57 and 1.84. So if you click up here, you'll see between. You can click on that and it changes it so you can find the area between two values. So this is going to be, type in negative 1.57 and then 1.84 here. When you hit compute, your picture comes up and you get 0.909. And that's what we calculated before, 0.909. Right? So I also have a template here, and it'll give you the same answers. So in this one, you have to type in the mean and the standard deviation, and then this time we're looking for your X. You're going to type in an X value. It's the same thing as the Z value. So in this case, we were looking at, was it 1.57 that we just did? Yes. So 1.57, I hit enter, and then we want less than. So this is the less than, and it's your answer is right next to it, and that's what we calculated. The other one was 1.84. Once again, the mean is 0 and the standard deviation is 1. We want 1.84, but we want everything greater than that. So that's this here, and it gives you the answer right next to it. Okay, 0.03288. Just round 0.033. And then the last one was between two values. So in this case, we're going to use our lower and the upper. It says L and U. So the lower was negative 1.57 and the upper is 1.84. Now unfortunately, I don't have the skills to design Excel to produce a picture for you like StatCrunch does, but it does give you, I can do the Excel commands and it gives you the correct answer. So in this one is 0.909, and that's what we calculated. So you want this one here where X is in between those two values, and we get 0.909. Okay. All right. So now we're going to talk about how to figure out the probability when you don't have a mean of 0 and a standard deviation of 1. So you're going to draw your picture like you usually do, And if you wish to continue using the normal distribution table, you're going to translate your x values into z values, and then you can use the table. Okay. So in this problem, we're going to let x represent the time it takes in seconds to download an image file from the internet. Suppose x is normal with a mean of 18 seconds and a standard deviation of 5 seconds. We want to figure out the probability that x is less than 18.6. Okay, so I got the visual. 18 is in the middle because that's the mean, and we want this area here. I put it in two different colors, but it should be all this. This is what we want, everything less than 18.6. Now, if you want to use the table, you can, but what will happen is you're going to have to take that 18.6 and convert it to a z value. And the reason being, your mean is not 0 and your standard deviation is not 1. So in order for you to use the table, you have to standardize the score. So you're going to take the 18.6, subtract off 18, which is the mean, and divide by the standard deviation. And then you get a z value of 0.12. So now if you look at this graph over here on the right, you now have a z, and you can use your table. Now the mean is 0, the standard deviation is 1 because you standardized it, and we're looking for the area to the left of 0.12. So if you go to your table, you got 0.1, then you go over to the 0.02, you get an answer of 0.5478. When you use technology, you do not have to convert your values to a z-score. You can go ahead and just input the mean and your x value and the standard deviation as well as your x value. So if we were to do this in StatCrunch, I'm going to go back to standard. We said the mean is 18 and the standard deviation was 5. We want everything less than 18.6. So once again, you don't have to standardize anything. You hit compute and you get 0.5477. And that's what we got when we did it with the table. We just rounded 0.5478. Okay. If you want to go ahead and use my template, go ahead and type in the mean and the standard deviation. The x value is 18.6. We're not doing in between numbers, so I can go ahead and delete that out. And if you look over here, we want everything less than 18.6, so that's this, and we get our answer, 0.54776. Okay. So in these next three problems that I do, I'm not going to use the normal distribution table. I just wanted to show you how to use the table because a lot of students like to work the problems out by hand because they feel like they better understand the concepts. When I was in college back in the day, I was taught using tables. Okay, so we didn't have all the fancy technology that we have today. So let's go ahead and look at this problem. A Nielsen study indicates that 18 to 34-year-olds spend a mean of 116 minutes watching video on their smartphones per week during the fourth quarter of 2016. Assume that the amount of time watching video on a smartphone per week is normally distributed and that the standard deviation is 15 minutes. So they give you a key here, keyword, normally distributed. So we know we have to use the normal distribution. We want to know what's the probability that an 18 to 34-year-old spends less than 97 minutes watching video on his or her smartphone per week. So once again, I'm a visual person. I like to draw pictures. So the mean is 116. We want to know the probability that they spend less than 97 minutes on watching video. So let's say 97 is here. We want this area right here. Okay. So we can go ahead and just punch this into StatCrunch. The mean is 116 and they told you the standard deviation is 15. So let's go ahead and punch this into StatCrunch to figure out what these answers would be. So we got the mean is 116 and the standard deviation is 15. We want everything less than 97. Hit compute and I get an answer of 0.103. Okay, 0.103. And the picture looks just like what we drew here. So this area here is 0.103. Go ahead and show you how to do it on my template. 116, 15, and we want 97. Oops, put it in the wrong spot. Have 97 right here. We want less than, I get the same answer, 0.103. The next one is the same scenario, but this time we want to find the probability that they spend between 97 and 129 minutes watching video. So the mean is 116. Sorry, I'm not really good at drawing here. And we want 97, let's say that's out here, and 129, that's over here. We want this area in here. So this is an in-between problem. It's in between two values. Okay, so let's go ahead and go to StatCrunch. And we want to go to the between one. So click on this. And this time we want, let's see, we want 97 and 129. 97 and 129. Hit compute. I get 0.704. 0.704. So the probability that they spend between 97 and 129 minutes watching video is 0.704. Let's go ahead and do it in my template. So this time we're going to use the lower and upper boundaries. The lower boundary is 97 and the upper boundary is 129. We want the in between. So that's this probability here, and we get 0.704. All right, same scenario, but this time we want to figure out what's the probability that they spend more than 129 minutes. Okay, so the mean is 116. We want more than 129. So we want this here. Okay, let's go ahead and do it in StatCrunch. We're going to go back to our standard one, and we want greater than, we want 129. Hit compute, we get 0.193. 0.193. And if we go ahead and do it in my template, I'm going to take out the lower and the upper, and I want 129 here, and I want the greater than, and I get also 0.193.